Here's problem 25:18. A particle charged 7.5 microcoulombs is released from rest at a point on the x-axis, x equal to 10 centimeters. It begins to move due to the presence of a 2 microcoulomb charge which remains fixed at the origin. What is the kinetic energy of the particle at the instant it passes the point x equal to 1 meter? Alright, so let's see what we got here. We have a charge at the origin, let's call that Q2, and that's equal to 2 microcoulombs. We have another charge, Q1, and that's 7.5 microcoulombs. It's going to start at a distance of 0.1 meters away, and then eventually we're going to find it at another location where it's moving with some velocity, and that actually is going to be our R2. So this first one is R1, and our R2 is going to be equal to 1 meter. And we want to find out how fast it's, or what's the kinetic energy at that point, 1 meter away. Well, let's find our change in potential due to charge Q2. That's going to be equal to KQ2 times 1 over R2 minus 1 over R1. And that would be 9 times 10 to the 9 times Q2, which is 2 microcoulombs. 1 over R2 is going to be 1 over 1 meter minus 1 over 0.1 meters. And what is this? It's going to be 18,000 times 1 minus 10, and that's going to be a negative 1.62 times 10 to the 5 volts. That's the potential difference that charge Q1 goes through. So our change in potential energy for it would be Q1 times that change in potential. So that's going to be equal to 7.5 microcoulombs times this change in potential we just calculated, negative 1.62 times 10 to the 5 volts. And that is equal to a negative 1.215 joules. That's our change in potential energy. We want to find the final kinetic energy. And now we know that since the change in potential energy plus the change in kinetic energy is equal to 0, our change in kinetic energy is the negative change in potential energy. So that would be the negative, which would be a positive 1.215 joules. And our change in kinetic energy is our final kinetic energy minus our initial kinetic energy. But in this case, we started from rest, so our initial kinetic energy is 0. So our final kinetic energy is indeed 1.22 joules, if we round it. That's the final kinetic energy of the charge as it's moving away from the charge at the origin, 1.22 joules.